Okay, so this is the first problem in the ungraded homework because we actually have the solution to the problem, but the solution is pretty short. So let me explain how to do this problem because it will help you with one of the graded problems. So the problem is chapter 1, problem 19. Alice searches for her term paper in her filing cabinet, and she knows that she left the term paper in a drawer with some probability pj, but if the term paper is in that drawer, when she searched for it, she only has some probability di of finding it. So the question is, what we're looking for are these conditional probabilities of what's the probability that the term paper is in drawer J, given that she looked at drawer I, but the search was unsuccessful. So the first thing we do is, as always, we define the event. So to use the notation in the solution, the solution says that event A is the event that Alice searches drawer I and does not find the paper. Right. And so we know that a complement is that Alice searches drawer I and does finds the paper. Right. And we also have this other event. Let's use the notation Bj to denote the event that paper is in drawer J. Right. So what we want is to find the probability of Bj given A, which is what the problem is asking. What's the probability that the term paper is in drawer J, given that Alice searches drawer I and did not find the paper? So obviously there's two cases here we can consider. So the first case is I does not equal J or I equals to J, right? So suppose Alice searches drawer number 1. The first case is, what's the probability the paper is in drawer number 2, given that she searched drawer number 1 and did not find the paper, versus what's the probability the paper is in drawer number 1, given that she searched drawer number 1 and did not find the paper. Right. So like in the solution, we'll do this first case first. So the probability of Bj given A, so again, by the definition of conditional probability, we know that this is the probability of A intersect Bj given divided by PA. So again, the numerator here, we're not told directly what's this probability, but we know that we can also apply the definition of conditional probability, and this we can get the probability of Bj given the probability of A given Bj divided by the probability of A, right? So the probability of Bj, so again, Bj is the probability that the paper is in drawer I. We're told in the problem that that probability is Pj. Right, so the probability that the term paper is in drawer J, we're told, is Pj. And the probability that of A given Bj, which is the probability that Alice searches drawer I and does not find paper, given the paper, which the event Bj occurs, which means the paper is in drawer J. Well, because the paper is in drawer J, when she searches drawer I, of course she doesn't find this paper. So automatically we know that this occurs with probability 1. right? So the numerator here is really PJ. So the difficult part to this problem, really the challenging part, has to do with finding the denominator PA, right? Which is the probability that Alice searches drawer I and does not find the paper, right? So again, this is like that coin toss problem where you have two tosses. What's the probability the first toss is ahead when you have two, the red coin or the blue coin? So we know that this can happen, right? That she searches drawer I and does not find the paper. Well, this has two possibilities, which is so that the paper is in drawer I, and Alice does not find the paper. Or the paper is not in drawer A. And Alice does not find the paper. So this, we know that this is the probability that the paper is in drawer I and Alice does not find the paper, or the paper is not in drawer I, right, which is BI complement, right, and Alice does not find the paper. So again, we can use the definition for conditional probabilities. We know that this is the probability of BJ, the probability times the probability of A given, probability of BI times the probability of A given BI plus the probability of BI complement given the probability of A given BI complement. Right. So we know that the probability of BI here, we know that this is PI, and that the probability that the paper is in drawer I and she does not find the paper, this is 1 minus DI, right? Because we're told that DI is the probability that she finds the term paper when it's in drawer I. Right. So this is the probability that the term paper is in drawer I and she finds it. So because the probability of A complement BI is DI, we know that the probability of A given BI is 1 minus DI. Right? So that's where this term comes in. Plus the probability of BI complement, which means the probability that the paper is not in drawer I, well, that's 1 minus PI. And the probability that the paper is not in drawer I and Alice does not find the paper in drawer I, well, that's with probability 1, because the paper is not in drawer I, and when she searches for it, of course, she doesn't find it. So this we see we have PI minus PI times DI, just multiplying across, plus 1 minus PI. So the two PI's cancel, so we'll have 1 minus PI DI. Right. So putting it together, we can go back to the original equation, and we know that the denominator is 1 minus PI DI, and the numerator is PJ times 1. Right. So this is PJ times 1 minus PI DI. So you can see that this is the solution given in the book. So in the solution, you see that in the denominator, they didn't go with this complicated step to explain what they get the denominator. The denominator is 1 minus PI DI, but they didn't do this. It's because they know that the solution, the denominator, you can see this as 1 minus probability of A complement, right? So, and you know that the probability of, you can break up the probability of A complement by considering if it's in drawer 1 or not, but don't, this way it's more complicated. So think of it breaking up this way, that the probability of you searching drawer I and not finding the paper, well, it could be that the paper is in drawer I but you did not find it, or the paper is not in drawer I and you did not find it, right? So the only difference now is this was the case when I does not equal to j. So now the case where I equals to j. So again, the conditional probability, this equation is actually very similar. So probably we have bi, so instead of j, it's equal to I, so we have bi given a. So similarly, we have on the top, the probability of a intersect with bi, probability of a. So we know that the denominator does not change, right? The denominator is still 1 minus pi di, because nothing here changed. The only thing that changes was the fact that j is now equal to I. So the numerator is now probability of bi given probability of a, probability of bi times probability of a given bi times the probability of a. So we know that probability of bi is equal to pi, and the probability of a given bi, this is 1 minus di, right? And the probability of a, which we found from the previous one, again, this is 1 minus pi di. So putting this together, now the probability of bi given a. So the probability that the thesis, or the term paper, is in drawer I, given that Alice searched for the term paper in drawer I and did not find any, this is pi times 1 minus di divided by 1 minus pi di, right? So you can see that this is not the same as this, because here we're asking if the term paper is in the drawer that Alice searched, whereas here we're asking if the term paper is in a drawer where Alice did not search, right? Okay, so that is very similar to how you can do the first problem in the graded section.